The first equation is 500 minus 128.00. Because the 0.00 is not necessary for 128, that means that it is a significant digit. Otherwise, we could have just left it off. For the 500, the two trailing zeros are necessary, otherwise it'd be a 50 or a 5. There's also no notation that marks the zeros as important as a decimal point after the 0 in the ones place or a bar over the whatever 0 is necessary. So we just do basic subtraction, which this will get us 361.00. However, because there's only one significant digit in 500 and there's 5 significant digits in 128.00, we have to go with the least precise decimal place, which would be the 1 in the 100s. So we have to round it, so we go to the tens place, round that to the nearest hundred, which 6 is greater than 5, therefore we round up to make it a 400. Next is multiplication, which we have 34.01 times 2. 34.01 has 4 significant digits, 2 only has 1 significant digit. With 2 being a guess, it can be plus or minus 1, so it could be 1 or 3. Just by moving 2 to 2.1 or from 2 to 1.9, there's a difference of 3.4 in either direction. Because 34.01 has 4 significant digits and 2 has only 1 significant digit, we go to the least number of significant digits, which is 1. So we go to the biggest number, in this case the tens place, which is a 60, and we round up the second biggest number, which in this case is the ones. So we round 8 up to a 68 up to a 70. For the prefixes in scientific notation, you might want to set up a number line with negatives and positives, and then you just write underneath or above the number whatever prefix it would be. One thing to note is 10 to the first just equals 10, and 10 to the 0th equals 1, so if you ever see times 10 to the 0, that just means times 1, so that's pointless. For scientific notation, the biggest decimal place you have is in the ones place, and then you just write the number accordingly, and then you multiply it by 10, and then how many times it moved either left or right. So for this example, it'd be 5.3 times 10 to the third, and 10 to the third is 1,000, so it'd be 5.3 times 1,000, or 5,300. Because it's only 5.3 in the scientific notation, that means there's only 2 significant digits. However, if there were any other digits, it would increase it as long as it's non like the tens or greater. If you have to include it in scientific notation, that means it is a significant number. A simple way to convert scientific notation to standard notation is look at the exponent on the 10 and just move the decimal place, whatever that exponent is. One way to tell where you're going to move the decimal place is if you were to look at a number line. If it's a negative, then you'd go left, just like on a number line. And if it was positive, you'd go right, just like on a number line. So this number would be 0.00048. If you were to look at it on the scientific form, you would notice that you don't even have to put the zeros, therefore it isn't significant digit. One way you can think of prefixes is as money. If it was 10 to the negative 1, which would equal 0.1, then that'd be like a dime. So you'd need 10 dimes to equal $1 bill. And so that's how you can get say like a meter, and you need like a decimeter. You need to convert it to decimeters. You have 1 meter but 10 decimeters. However, say you have a dime and you need to convert it to money, to $1 bill, then you'd have 10 cents to $0.1. The formula to calculate volume is length times height times width. The formula to calculate surface area, or just a two-plane, is length times height. So for the height, let's put 5. For the width, let's put 2. And for the length, let's put 3. You just do 2 times 3 times 5, which is 6 times 5, which is 30. Let's put the mass as 150 and y just as the units. So in this case, 150y divided by 30x equals 5y over x. Y could be, say, like grams, and x could be, say, centimeters cubed because it's a 3D object. It could also be in liters, and so you just have to put the mass over volume. In this case, the mass happens to be greater than the volume. That's not always the case. It could be switched where, say, 30 is the mass and 150 is the volume. In this case, it will be 1/5 y over x. There are 4 states of matter: gas, liquid, solid, plasma. The gas is spread apart in whatever container it has because it does not want to touch. The liquid is free-flowing and fills up the volume of whatever container it's put on. A solid usually has an orderly pattern, however it can be a disorderly pattern, and it has a fixed shape and cannot change without having some sort of force applied. Physical changes are something that does not change the chemical property or structure of an object. One example of a physical change is cutting a piece of paper. One example of a chemical change would be burning a piece of paper, because the paper itself, those compounds get broken down and it creates new compounds. Another example of a physical change is a change of state of matter, which is a solid to a liquid to a gas to a solid, or a solid to a gas. Yes, solid to gas to solid actually does happen sometimes, rarely though. It requires a lot of energy. And for this to be true, it has to require no change in the compound. And so one example of melting would be ice, H2O, to water, which is just liquid ice, or ice is just solid water, which at the end it's still H2O. We'll probably learn that second semester, but basically what it's saying is you change the bonds of the water and the carbon to where the carbon bonds with the oxygen in the water to create CO2, And the reason why it's 2 parentheses H2O is because you can't just have, say, 2 oxygen atoms out of nowhere. You have to have 2 already in the equation. One example of an element is a diamond, which is just pure carbon. Graphite is also pure carbon. One easy way to tell if it is a compound or if it's an element is if you can find it on the periodic table of elements, then it's an element. So if you are supplied with the periodic table and you're not sure if it's an element or not, then you can just look at the periodic table. In this example, there are 2 blue, 1 yellow, 1 magenta, and 2 red. In this example, there's the same amount of the colors. In this example, there is 1 yellow, 1 magenta, 3 purple, and 1 black. But in the other group, there are 2 magenta, 1 purple, 2 blacks, and 2 yellows. Another example of a heterogeneous mixture would be if you were to mix 2 things but they separate, like water and oil. In this example, we know the element helium, which has an atomic number of 2, and its mass, which is 4. And so the equation for this is atomic mass minus atomic number, so 4 minus 2, which equals 2 to get the neutron number. An equation to figure out the electron number is atomic number minus x, which is the electron number, equals y, and y is the charge. So in this case, the charge is 0 and the atomic number is 2, so 2 minus x equals 0. Subtract 2 from both sides to get negative x equals negative 2, multiply by a negative 1 to get x equals 2. So that means there are 2 electrons. So in this case, it has a positive 1 charge. So again, you set it up with atomic number minus x equals the charge, which is 1. You subtract 2 from both sides. So 1 minus 2 equals negative 1. Multiply it by negative 1 to cancel out the negative sign on the x. You get x equals 1, which means there's only 1 electron.